All right, APCal. What I'm going to attempt to do here is kind of toss in a little artifact, okay, of the day to kind of guide the instruction. Overall, we're doing amazing, okay, but I thought in case things get a little difficult, I kind of start that trend. Again, I'm just kind of playing with this idea, so let's get straight into it. You can pause, kind of read that very powerful Zig Ziglar quote. But yeah, let's go and get straight into it, okay? I'm hoping these are short and sweet, and we have a prompt. And it reads like this: a spherical balloon is inflated with gas at the rate of 800 cubic centimeters per minute. How fast is the radius of the balloon increasing at the instant the radius is A, 30 centimeters and 60 centimeters? Okay. So again, you guys have been doing awesome. I love, I believe learning has more to do with exploration than being told what to do. But again, in case things get a little too tough down the line, this might actually play a role here, okay? So I'll keep them short and sweet, so let's get straight into it. If you're looking at a problem like this, what you want to do is kind of really extract what's explicitly provided and implicitly suggested, okay? So if you're reading this and thinking inflation, volume might come to mind. Again, it depends on kind of where you're at with these concepts, but definitely once I get to cubic centimeters, right, we've got the three dimensions, then I'm pretty confident we're dealing with volume, okay? So volume what of a sphere is essentially what 4. This is a quick search, not that everybody has it on top of their heads, but you can do a quick search, okay? All right, and what else comes to mind is this rate that they're describing here, right? The rate of 800 cubic centimeters per minute. So you guys know how to write rate. How do you write rate, right? And what is in terms of what? T, time, right? Per minute. So here's volume being described as cubic centimeters per minute. So there's how you can be assured that you're using the right units. And it's clearly suggested that it's 800. Okay? All right. So what do we got? Essentially per minute. Okay? All right. So from there, what do we do? What would be the logical thing? Well, we are being given volume. We know that we've got a rate provided, so we can go and explore further that rate. Okay, kind of come up with a formula for volume to kind of model this scenario. Okay, so let's go and do that. Here's the rate. Let's go and produce that appropriate formula. So if, and we'll skip the details, but I think most of you guys can perform this in your minds, in your heads. Okay, we would pretty much have 4 pi r squared, right? If you're not sure, you can ask in class, but I'm sure we're kind of past that at this point. And here's that portion that kind of hung us up the other day, okay, which is that chain component, right? We're taking the derivative in terms of t, so we've got to introduce that link, right, that we were kind of describing in class, okay? So from here, okay, we've got pretty much our formula for this change, okay, this rate change. Now we go back to the prompt and notice that they're asking us about what? Essentially a formula for the radius, okay? Rate of change formula for the radius. So here we have it in terms of volume. So what do? Okay, you can pause the video, kind of think about it. If you did do that, then you're probably thinking, how about do some traditional algebra, okay? Which we can divide both sides by what? By 4 pi r squared. So then we would have what? And now we have our formula for the rate of change of radius per unit of time, okay? Which is pretty powerful stuff here, okay? Now, where do we go from here? Okay, we were given this rate, right? So let's go ahead and plug that in so that this formula becomes that much more appropriate to this given scenario. Okay, and at this point, whoops, what would be the next logical step. Okay, if you said, to carry out, simplify this, then move on to the scenario where they give us A, you'd plug in for the radius, B, you'd plug in for that other radius, and kind of proceed from there. Okay, hopefully that helps. If you have any questions, we'll address them in class. Thanks for your time.